Alright, so today we're going to go over derivatives of trig functions. Okay, so the first thing we're going to talk about are sine and cosine. Okay, so the derivative of sine of x is actually equal to cosine of x, and the derivative of cosine of x is equal to negative sine of x. Straighten that out just a hair. Alright, so we're going to go ahead and prove the first one because the proofs are so similar, there's no real point in proving them both. Okay, now for this one, we just have to remember a few little key details. Okay, so you want to remember, bless you, the limit sine of x over x as x approaches 0 is equal to 1, and the limit of 1 minus cosine of x over x as x approaches 0 equals 0. Okay, so those two are actually going to come back in this proof. Okay, so
The limit as x approaches, like x was it or something like that, I thought, or?
No, x approaches x.
There was one of them where it's like divided by 1, and then there's another one where it's divided by 2 or something. I thought it was something like that, how they differentiate.
That doesn't ring a bell. Alright, so just starting off this proof, derivative of sine of x is just the limit of your f of x plus h, which is sine of x plus h, minus your f of x, so minus sine of x, all over h as h approaches 0. Okay. So if you go way back to trig, and you remember that sine of x plus h is equal to sine of x cosine of h plus cosine of x sine of h. And that's from the sum formula. And trig. So pretty sure it's been a while since you actually had to use it, so a little refresher. Okay, so this sine of x plus h is going to equal the limit as h approaches 0, sine of x cosine of h plus cosine of x sine of h minus sine of x all over h. All right, so we're going to move this sine of x over here. Okay, so we have the limit h approaches 0 of cosine of x sine of h plus sine of x cosine of h minus sine of x all over, h. All right, so now we're going to factor a negative sine x from those two. Just the limit as h approaches 0, and we're actually going to factor the cosine x down to the front. So you have the limit of cosine of x times sine of h over h. We just got the h, and we're going to separate these two. Okay. Minus, plus. Sorry about that. Bless you. Nope, actually it is minus because we factored out a -1. Negative sine of x.
What did you take out of the first one?
Oh, the first one, I just factored
No,
the...
up one more.
Oh, this one? Oh, this one.
Yeah, that one. Did
Oh,
you
I...
factor out something out of that one?
Oh, no, all I did was replace the sine of x plus
okay.
h with that. All right. So it's minus, since we factored out a minus sine of x, the limit, remember that's going to be sine of x, 1 minus cosine of h, all over h, as h approaches 0. Okay, so if we factored out a negative sine of x, that will make that positive 1 minus cosine of h. So I just kind of switch them around. Okay, so we're going to get this cosine, and we're going to do the same thing here, this sine, and just bring it right out to the front. As h approaches 0, okay, so the limit of cosine of x times the limit of sine of h over h as h approaches 0. Minus, since we're bringing that sine of x to the front, we have the limit sine of x as h approaches 0 times the limit of 1 minus cosine of h over h. As h approaches 0. Okay, so now we can go back to the formula we knew already. So we know the limit of sine of x over x is equal to 1. So the limit of sine of h over h is also equal to 1. So you have the limit of cosine of x. If we plug in h equals 0, doesn't really mean anything. So you have cosine of x times 1. Minus limit of sine of x. If you plug in h equals 0, it doesn't mean a thing because you just get sine of x. And we know the limit of 1 minus cosine of h over h as h approaches 0 from up here is equal to 0. Okay, so 0 times anything is just 0, so that disappears. So now you're left with cosine of x. So that's your proof. All right. Any questions on that one? Yes.
So theoretically, you factored out from going from the bracket cosine x. That was just factored out.
From this one, yes.
Right.
Because all we did was separate this half and that half.
Now, where did you get the subtraction from when you subtracted the limit? Was that factoring out also the sine of x?
Yep, we factored out negative sine of x from these two. So since we factored out a negative, that made that positive and that negative. So you had a negative cosine of h. So since we had a negative cosine of h here, I just moved it out to the front.
Okay, and then the 1 minus comes from because we factored out sine.
Yeah, we factored out negative sine.
Right, because cosine, okay, because I'm trying to think of, so we basically factored out two different things, and you could technically replace it with one since one is a...
Yep, so what we did here, just on this step, let me see if I can find a little bit of room. If you had, let's say if we distribute that back out. So sine and 1 minus cosine of h. If we distribute that back out, well, negative sine actually. You end up with negative sine plus sine times cosine of h, which is what we have here. Only difference is they're kind of switched around.
Okay, I think I see that, yeah.
Yeah, so just by that little switch is probably what confused you.
Yeah, that's what it is.
Yeah.
And then there's also that one takes the property of sine of x, cosine of h, right?
Which part?
when you factored it out back into it, it was minus sine plus sine. Would that be sine of x multiplied by cosine of h, which is what we have in the previous? Okay.
Yep, which is what we had up here.
Okay.
Yep.
Okay. Thank you.
Oh, no problem. Yes.
So one step down, why, I might just be doing my arithmetic wrong. Is
Mhm.
there supposed to be an h underneath the sine of x next to the limit of one, two, 3, the fourth line down? That
Where,
right
this
there.
one?
Yeah, there's not supposed to be an h underneath?
Only if they were added or subtracted. If they're multiplied, you can just kind of separate them.
For sure.
All right. Any other questions on this one? All right. Anyone still writing? Nope. I'll leave that up for a few seconds. Yes.
I know you just answered this.
Mm-hmm.
How did, after you factored out the negative sine of x,
Mm-hmm.
how did you get from cosine of h plus 1 to 1 minus cosine of h?
Oh, because if you, let me see if I can get this on a separate sheet. So if we have the sine of x cosine of h minus sine of x, if we factored out negative sine of x, we'd end up with negative sine of x, but we'd have negative cosine of h plus 1. Because if we distribute that back out, the negatives will become positive,
All right.
and that would just become negative. So all I did was switch those two around to make it 1 minus cosine of h.
That makes sense.
All right. All right. Does that make sense? All right.
Oh, means we go home, right?
And then that
This
negative
is
sine applies to all.
Proof number 1 of 6. The others are a lot shorter.
And then this, the negative would technically apply to all of it.
For,
You could just say, you could put a parentheses around, the whole entire equation beside, or, not the whole entire equation, but
Mhm.
at that portion.
Oh,
So
for
that you
this
get
one?
the minus limit, okay.
oh, yeah, yep,
Yeah.
for that one. Yep,
Yeah,
that's
for
what I
the
did.
example, sorry.
Oh, no problem. All right. So let's go to actually using it, which is a lot easier. Okay, so for example, I want to find the derivative of, let's say for A, f of x equals 2 sine of x. And for B, let's say g of x is equal to sine of x over 2. And let's throw one more in there. We'll say C is h of x is equal to x plus cosine of x. Okay, so you know if we're doing 3 examples on one page, they're not that long. Okay, so for A, we have our f of x equals 2 sine of x. So our f prime of x is going to equal 2 times the derivative of sine of x. Okay, so we know the derivative of sine of x is cosine of x. So f prime of x just equals 2 times cosine of x. And that's it. Okay, now for B, you have g of x equals sine of x over 2. You can actually rewrite that as g of x equals 1/2 times sine of x. Okay, so our g prime of x is going to equal 1/2, just bring that right out to the front, times the derivative of sine of x. Yep, which is cosine of x. So our g prime of x is equal to 1/2 cosine of x.
Could cosine over 2 be applicable still?
Oh yeah, you can put it as cosine over 2.
And then if you really want to be extra, you could have done the quotient rule.
Oh yeah, that would have been a whole lot of extra work, but you would have got the same
I
thing.
noticed.
Oh, that's what you did?
Yeah.
Yeah, the quotient rule, if you can factor out a fraction, it just makes it easier. If you had a, let's say, cosine of x over 3x, then maybe then, but that's if you have like two functions. All right, so for C, h of x is equal to x plus cosine of x. All right, so our h prime of x is just the derivative of x plus the derivative of cosine x. Okay, so we know the derivative of x is just 1. Plus derivative of cosine x is negative sine x. Okay, so that means our h prime of x is 1 minus sine x. All right, so any questions on that one? All right, I'll leave that up there for a few seconds.
I have a question.
Sure.
On a test, if we go for just x plus cosine of x and show the derivative, skip like the 2 in between, just do 1 minus.
Oh yeah, if you went from,
Is that showing enough work?
you went from here
Just at the bottom?
to there?
Yeah.
Because that's pretty straightforward.
Okay, just making sure.
All right. Let's do that one. Okay, so let's say if we wanted to find the derivative of f of x equals negative cosine of x plus sine of x at the point x equals negative pi over 2. Oops. All right, so since we have a negative cosine of x here, our f prime of x is going to equal negative 1 times the derivative of cosine of x plus the derivative of sine of x. Okay, so since we know that we have negative 1, the derivative of cosine of x is negative sine x, and the derivative of sine of x is cosine of x. Okay, so which gives us negative and negative is positive, so you just have sine of x plus cosine of x. Okay. So now we have to find the derivative at x equals negative pi over 2. So when x equals negative pi over 2, it gives us f prime of pi over 2. Which is equal to sine of negative pi over 2 plus cosine of negative pi over 2.
Isn't that supposed to be f prime of negative pi over 2?
Oh, I forgot my negative. Yeah, thanks. Yep, so it should be -1 plus 0, which is -1. Okay, so if you looked at a graph of negative cosine of x plus sine of x, the slope at negative power 2 would be -1. All right. Any questions on that one? All right. All right, so it's, oh, sorry, that's someone's still writing. Oh, just a little side note. Instead of writing d dx of cosine of x, you could also write just cosine of x prime. So if you want to do that, you could, instead of writing out the d dx each and every time. Okay. Both means the derivative of cosine of x. All right. Okay, so let's say, for example, I want to find the derivative of f of x equals -2x to the third minus x squared plus x minus 2 times cosine of x. Okay, so here you have the product of two functions and you're trying to find the derivative. So you're going to use the product rule. Okay, remember the product rule is, oh, so if you have the derivative of two functions, be f and g, let's say f of x times some function g of x, it's going to be the first function times the derivative of the second plus the second function times the derivative of the first. So first, second, second, first. At least that's how I remember. Okay. So in this one, our f prime of x is going to equal to our first derivative, or in our first function rather, 2x to the third minus x squared plus x minus 2 times the derivative of the second. Let's say cosine, I should have moved that over, I'm running out of room. Cosine of x prime plus the second cosine of x times the derivative of the first. So you have -2x to the third minus x squared plus x minus 2 prime. That kind of avoids all the ddx over and over again. Okay, so you have your first, -2x to the third minus x squared plus x minus 2 times the derivative of cosine, which is negative sine, plus, straighten that plus sign out a little bit, cosine of x times the derivative of that function, which we know we have to bring the 3 down, so that's -6x squared, and subtract 1, minus, bring that 2 down, subtract 1, so that's 2x to the first, plus derivative of x is just 1, and derivative of a constant is 0, so that disappears. Okay. And then from there, we just kind of simplify it. So if you wanted, you could bring your negative up front here, or even if you felt like it, you can just make it cosine of x, negative 6 x squared minus 2x plus 1, minus, just bringing that negative up front, negative 2x to the third minus x squared plus x minus 2 times sine of x. Either way you organize it, it would still be correct. So, just a lot of little moving parts in a problem like that. All right, any questions on that one? Oh, move that down. So.
Why do we have to find the derivative of the first cosine?
Oh, because of the product rule, you have the first function times the derivative of the second, plus the second function times the derivative of the first. So it's just in that order. Yes.
Just wondering for the quotient, it's the numerator, or is it the derivative of the numerator first, or is it the
For the
denominator?
quotient, it's the denominator. Actually, we're going to do an example for the quotient rule too. So we'll go over that too. I know that one's a little bit tricky. Oh, I'm still writing. All right. Excuse me. Okay, so let's do one more just to kind of get a little bit of practice in for this one. Oh, well, we got to find the derivative first. F of x equals, oh, wait a minute, did I rewrite that one again? Nope, it's different. I don't know why that looked pretty similar to the other one. X to the third minus 2x squared minus 2x times sine of x. All right, and that's getting ready to shut off in like 3 minutes.